Hello everyone. This lab we're going to discuss a Y to Y three-phase transformer bank connection and the calculations. So, in the lab, we all have a dual winding transformer. Each transformer is rated 240 volt, 480 volt for the high voltage side, 120 volt, 240 volt for the low voltage side. And each transformer is rated 1.5 kVA. So the lab requires us to wire them the primary side in parallel and the secondary side also in parallel. So here's my parallel connection. For each dual winding transformer, I will connect H1, H3 together, H2, H4 together. When I connect them in parallel, then I connect the primary in Y, H1 connect line A, H4 connect on neutral. Secondary side also a parallel Y connection. So X1, X3 connect together, X2, X4 connect together. And by following CSA phase displacement, in Y to Y transformer have 0 degree phase displacement. So H1 connect to line A, H4 connect to neutral. I connect each of the phase transformer in the same way. So here's the connection diagram down here. I think somehow this line got erased a little bit. Now we can do the calculations. Primary side, line voltage is 240 volts. It's a Y connection. So the phase voltage is going to be √3 lower. 240 divided by √3 gave me 138.6 volts. Secondary, I always do the voltage calculation from the supply to the low, then do the current calculation from the low back to the supply. Because transformer have 2-to-1 ratio, so secondary phase voltage is going to be equal to primary phase voltage divided by 2. Give me 69.3 volts. Secondary line voltage, Y connection, line voltage is going to be √3 higher, 69.3 times √3, give me 120 volts. Current is always come from the low, so I'm going to use the secondary phase voltage, also will be the phase voltage for the low, because my low is also a Y connected. So from a secondary line voltage come to the low will have the same phase voltage as my secondary phase. Secondary phase current, phase voltage divided by resistance, 69.3 divided by 15 ohm, give me 4.62 amps. Because it's a Y connection, so the line current gonna equal to the phase current. It's also 4.62 amps. Now I can calculate the total low kVA. I use the phase value, 3 times E phase times I phase, give me total 960 VA. Because it's a full resistive load, you can also call it 960 watts. Once I get this, I can calculate my primary line current or phase current. It's a Y connection, so phase current, line current will be the same. I'm going to use the total kVA of the load to calculate my phase current and the line current. So 960 divided by 3 times the phase voltage on the primary side, give me 2.31 amps. If I'm using for the line value, I have the same number. Here's the one thing I want to remind you. When I figure out the line current and the phase current, I use the load kVA to do the calculation for the current. I didn't use the transformer kVA because the transformer kVA, 1.5 kVA each, is going to deciding the maximum current on the primary side and the secondary side. But when I have a load there, the load kVA going to use to do the calculation for the phase current and the line current. If you remember, we're talking about in the classroom, we have a Y connected secondary transformer, we have to check for 3 balanced line voltage. So if I connect all my transformer right, I will have a 3-phase voltage at 120 degrees apart. So when I check my straight line voltage, that will be also equal to each other. In this example, each phase voltage on the secondary side, 69.3 volts, and 120 degrees apart. So my line voltage here will be 120, 120, and 120. If I connect any of the transformer winding wrong, then instead that phase voltage go into the right direction, 120 degrees apart, one of the phase voltage will be flip over to become 60 degrees apart between the three phase voltage. Then I will have an unbalanced secondary line voltage at 120, 69.3, 69.3. Because this part, when I flip it, it becomes 60 degrees here, 60 degrees here. It's an equilateral triangle. So instead of reading two line voltage, I read the two phase voltage down here. So right connection, three balanced line voltage. Wrong connection, you only read one line voltage, and you're going to read two phase voltage. So here's the calculation I showed you. I'm going to go to the lab bench to show you the lab measurement.